Here we have the function f of x equal to x squared minus 5. And so the derivative is 2x. And what we want to do is use Newton's method to find the zeros of this function, or the x-intercepts of this function right here. And so recall that to use Newton's method, what we do is we start with an initial guess, and then we calculate the y value corresponding to the initial guess, and then we calculate the derivative, evaluate the derivative at the initial guess. And then in an earlier video, we have shown that this is the x-intercept of the new tangent line. And then what we want to do next is calculate the difference between the guess and the x-intercept of the new tangent line. And so this is the graph for the function x squared minus 5, and we want to find the zeros or the x-intercepts right here. So this looks like about 2.2, and this looks like about negative 2.2. And recall that using Newton's method, what we do is first, let's say we want to know what is that x-intercept. First, pick the number close to the x-intercept. Let's say we pick 1. And so our initial guess is 1. And then we would draw the tangent line. And so this is 1. And when x is 1, y is negative 3. And then we would find this tangent line. And then find the x-intercept of the tangent line. And then use that as the new guess of the zero of the function. And so we would repeat this process until we get the x-intercept to be real close to the zero of the function. And so doing it manually. And so our iteration 1 right here, our initial guess is 1. And then we want the y value corresponding to the 1. And so we would do f of 1. And so we put a 1 in here. 1 squared minus 5 would be negative 4. And then next, we need to evaluate the derivative at 1. And so it would be 2 times 1, which is 2. And then next, we need to calculate, remember that this is the slope of the tangent line. And so next, we need to calculate the x-intercept of the tangent line, which is x sub I minus this dividing by the derivative here. And so in this case, it will be 1 minus f of x sub I is negative 4, and then dividing by f the derivative is the 2. And so this would equal to 3. And then last, we want to compare the x-intercept of the new tangent line with the guess value. And so we would do the absolute value of 1 minus 3. So absolute value of 1 minus 3, which is equal to 2. And so this difference right here is too large. And notice that if we do x sub I minus this, then it just becomes, we just get the f of x sub I divided by the derivative. And so the difference here is too large, and so we'll go to iteration number 2. And recorded in iteration number 2, for the guess value, we would start with the x-intercept of the first tangent line. So this time it'd be 3, and then repeat the process all over again. And so when x is 3, then y is 3 squared minus 5, which is 4. And then the derivative when x is 3, y is 6. And then here we calculate the x-intercept of the second tangent line. And so it would be 3 minus, and then it would be 4 divided by 6. And this comes out to be 2.333. And the next, we want to find the difference between the guess and the new x-intercept, the x-intercept of the second tangent line. And so it's going to be absolute value of 3 minus 2.333. And this would be about 0.666. And again, the iteration is too large, and so we go to iteration number 3. And so we can see that the process of getting to the zero of the function, depending on how many iterations, that is going to be very tedious. And this is where Google Spreadsheet or Microsoft Excel will be useful. And so let's go to Google Spreadsheet, since it's free and anybody can have access to it. And then we'll put all of this in and let Google Spreadsheet do the calculations. And so this is Google Spreadsheet. And so first, let's go ahead and label the columns with what we need. So this is the iteration. This is x sub I. And then right here, this is f of x sub I. And then this is the derivative of f of x sub I. And this is the x-intercept of the tangent line. And then the last column will be the difference between the guess and the slope and the x-intercept of the tangent line. And so in our example, our initial guess was 1, and recorded our function is f of x equal to x squared minus 5. And so we want to put this formula of x squared minus 5 right in here. And this is how we would do it. So we do equal, and it's x squared minus 5. And the x value is in the b column. And so we want to do b2, which is this value right here, and square. It would be hat square minus 5. And it will calculate it for us. And recorded the derivative function is 2x. And so right here, we will do 2 times the guess value. So it'll be 2 times cell B2. So we do equal 2 times B2. And then right here, we will do x sub I minus f of x sub I dividing by the derivative of x sub I. And so equal x sub I is in cell B2, so clicked on it, and then minus, and then f of x sub I is in cell C2, so clicked on it, and then divide. F prime of x sub I is in cell D2, so clicked on it, and then enter. And so we get 3. And then the last column, we want the difference between the guess value, and remember that this is the x-intercept of the first tangent line. And so we want the absolute value, so equal ABS for absolute value. When we type in ABS, then the spreadsheet will know we want the function absolute value. And it's going to be absolute value of the guess, which is B2, and then minus the new x-intercept, or the sec-intercept of the tangent line, which is in E2. And that will be 2. And then we know that the difference is 2, so we want to go to the next iteration. And remember that in iteration 2, the guess value will be the x-intercept of the first of the previous tangent line. In this case, is in E2. So we want to type equal E2. And then after we put in the initial guess, we want the process to be the same again. And so highlight these cells right here and then copy Control C. So Control C on the keyboard. And then click on this cell and Control V. V is in Victor. And then Control V. And it will copy and paste. And so at the end of iteration 2, the difference between the guess value and the x-intercept of the second tangent line is 0.6, so the difference is too large, and we want to start it all over again. And so again, the new guess value, the guess value for iteration 3 will be the x-intercept of the tangent line from iteration 2. So this will be E3. So equal to E3. And this will be our new guess value. And then now we want the process to start all over again. So highlight these cells right here. And then Control C for copy. And then Control V for paste. The difference here is still too large, so we want to go to iteration 4. So equal, and this time the new guess value of the fourth iteration will be the x-intercept of the third tangent line, which is in cell E4. So this will be equal E4. And again, we want the process to start all over again, so highlight and then Control C and then click on this cell and then Control V. And now the difference between the guess and the new x-intercept of the tangent line is getting smaller. We're still not happy with this difference, so we want to go to iteration number 5. And so the new guess will be this, which is E5. And then copy, Control C, and now Control V. And if we're happy with this difference here, then the x-intercept of the of f of x will be 2.236. And if we look at the graph, the x-intercept right here is 2.236 after 5 iterations. And now let's say we want to find this x-intercept, and we want to have an initial guess of -2. So we want to start, remember to get for Newton's method, if we want to know what this x-intercept is, just pick the number close to it, but to the left of it, or to the right of it, which is, so let's pick -3 for the initial guess, -3 right here. So we just go back to the spreadsheet, and then right here in our initial guess, we will have -3. And once we put in -3, the formulas are still in the spreadsheet, and so everything will just get updated automatically. And the reason it's 0 here, because there are too many zeros, and Google Spreadsheet only takes so many zeros. So if we have like about 8 or 9 zeros after the decimal point, then Google Spreadsheet would just count that as 0. And so the x-intercept of the graph of f of x on the other side is negative 2.36. And so that's how we can use Google Spreadsheet to help us do the calculations.